Okay guys, today we're going to start polynomial word problems. And so with these problems we're going to be using how we solved the polynomials in the last lesson to solve applications and word problems. So the first one we're going to look at says, Shannon has finished weaving the blanket. She wanted the length of the blanket to be 1 foot more than twice the width because otherwise her feet hang out and her toes get cold. If the area covered by the blanket is 28 feet, what are the dimensions of the blanket? Okay, the first thing I'm always going to do is draw a picture. So I'm going to draw this blanket, and it says that she wants the length of the blanket to be 1 foot more than twice the width. Okay, so I'm going to make the length of the blanket be 1 foot more than twice the width. This is x, my width, and then the length would be twice that, so 2x, and then 1 foot more than that, plus 1. Now, it tells me that I'm finding, or that I have the area. So the area, I'm going to write that formula down as length times width. So if I want my area to be 28, I'm going to plug that in for A, and then my length and width are going to be x times 2x plus 1. Now, we're going to make this as easy on ourselves as possible. So what I'm going to do, if I want to find the dimensions, I'm going to subtract this 28 over, and I'm not going to simplify this out. You can if you want, but it's going to end up giving us the same answer when we plug it into the calculator. So I'm just going to make the work easier on myself, and I'm not going to multiply this out. And so I'm going to plug this in exactly like it is and find the zeros since this is equal to 0. So when I plug this in, I am plugging in x times 2x plus 1 minus 28. And I'm always going to start in my window with zoom 6, okay? So now, if I'm trying to find the 0, those are these two solutions right here, these two roots, okay? So I'm definitely not going to try to find a negative root over here because that doesn't make sense to have a negative dimension for a blanket, okay? So I'm going to find the positive root. So I'm going to go to second calc and find the 0. And then I'm going to go to the left. So the left is going to be somewhere below this. So my y value will be negative. So I'm going to go ahead and hit enter. And then to the right of that 0 is going to be somewhere up here. So that needs to be positive, a positive y value. And so when I find that, I see that my... Okay, so this means my root here is 3.5, or x is 3.5. So whenever I go back over here, I found what x is. X is 3.5, and we need to make sure we put units. So my units are feet. So x is feet. So if I'm finding the other dimension, I'm going to say 2 times 3.5 plus 1. And when I do that, that's going to give me 8 feet. So I'm going to come down here and say that my width, I let that be x. So my width is 3.5 feet. My length is 8 feet. And then this is my final answer because those are the dimensions of the blanket. Alright, number 2. It says an open box is to be made from a square piece of material by cutting 2 centimeter squares from the corners. So I'm going to go ahead and label all these little squares 2 centimeters and turning up the sides. The volume of the finished box is to be 200 cubic centimeters. Find the dimensions of the box and the area of the original piece of material. Alright, the first thing I'm going to write down is volume is length times width times height. Okay, so I know this is a square, so all the sides are going to be equal. I don't know what the length of this side is, so I'm going to let it be x. And then these 2 centimeter squares that I'm cutting out are going to end up taking away 4 centimeters off of that side of the square. When I fold it up, that little distance is not going to be there anymore. So I've got to make sure I take away 4 centimeters from that x. So now, since this is a square, that means this side's also x minus 4, and so are the other two. So whenever I go to do my volume, the length and the width are going to be the same. It's just going to be x minus 4, but the height, when I fold these corners, or these little flaps up that are made when I cut those squares off, that's going to end up giving me a height of 2 centimeters when I fold that up. So I'm going to write this as x minus 4 times x minus 4 times 2. Alright, so then to just write it and make it look a little simpler, and I'll also go ahead and plug in 200 for the volume. So 200 is going to equal, I'm going to write this as 2, and then x minus 4, we've got 2 of those, so I'm going to square it. Now, if I want to find the dimensions of the box, I'm going to take this 200 and subtract it over. So 0 is going to equal 2 times x minus 4 squared minus 200. And this is one where it's going to be easier, a lot easier, to just leave this unmultiplied out, because it's going to end up giving us the same answer. So I'm going to go plug this in. So clear. And so I'm plugging in 2 times x minus 4 squared, and then subtracting that 200, and I'm trying to find the dimensions, and when I did that, I had this set equal to 0, so that tells me I'm going to find a 0. Alright, now it doesn't make sense for this 0 to be negative. It doesn't make sense for me to have a negative value for my dimension. So I probably need to change my window so I can see further out here to see if there's a positive 0. So I'm going to go to my window and change that x max because I need to see more to the right. I'm going to make it 20. That's just a number you'll have to play around with. So right here I can see that I do have a positive dimension. So I'm going to go ahead and find that by finding the 0. And so then left is definitely going to be negative. I'm just going to go ahead and hit enter. To the right is going to need to be positive, so I'm going to scroll up or over until I get to a positive number. There's a positive. And so that 0 is 14. Okay, so I know that x is 14. Now, if x is 14, the dimensions of the box are after we fold up those two corners. So the dimensions of the box are just going to end up being, I want to find length, width, and height. I already know that the height is going to be 2 when I fold that up. And so then both of the dimensions are going to end up being 14 minus 4, which is 10. 14 minus 4, which is 10. So these are going to be centimeters. And that should make sense because 10 times 10 times 2 is 200, and so that would give us a volume of 200. Now, last thing I need to find is the area. So the area of the original piece of material. Now, x represents what this side is before I subtract 4. So the original piece of material is just going to be 14 squared, okay, or 14 times 14. And so then 14 squared is just going to end up giving me, 14 squared gives me 196. So the area of the original piece of material is going to give me 196 centimeters squared, and we need to make sure we put our units on there correctly. Okay, so that's how we're going to do that one. Okay, number 3. Alright, this one says, suppose you have a 4 foot by 8 foot piece of plywood. If the corners are cut so that the sides can be folded up to make an open box, what is the maximum volume you can make without a top? Alright, so this one, if we're trying to find volume, or the maximum volume, I'm going to have the formula length times width times height again. Alright, now, they've got this picture labeled for us already, so we know that we're cutting off some side length x on this one. And so, the way that I'm going to set this up is this is going to be my length, this is going to be my width, and then the x will end up being the height once we fold up those corners of the box. So the volume is going to equal x times 4 minus 2x times 8 minus 2x. Alright, so now this one is a little bit different because they didn't tell us what the volume would be. Our goal is to try to maximize or create the biggest volume possible for this box. And so we don't know what x should be, what size we should cut out for this corner to make the biggest possible box. And so whenever you have a problem that says find the maximum volume or maximum area or whatever the case is, you always want to find a max on your function, okay, the max on your function. So this is not a problem where we're going to find a 0. So I'm going to go ahead and plug this in. So my function or formula is x times 8 minus 2x and then 4 minus 2x. Alright, and I'm always going to keep my window, or I'm going to start in zoom 6. Now, I want to find the maximum of this function, so I can tell that it's somewhere up here. Okay, so I'm going to change my window to make it a little bit bigger than 10. I'm going to change my y max to, I'm going to try 15 since it looks like it's already close to being able to see it. So once I do that, I can see the maximum, and so that's what I'm going to find. So I'm going to find the max. I'm going to go to the left of the max, and then to the right of the max. And so then that maximum, the maximum volume is going to be this y coordinate, okay? This would be, this x equals, this is the size of that corner that we need to cut. Okay, so that 0.845 is how much we need to cut 0.845 feet out of each corner to get that maximum volume. So the maximum volume for the box that we can make is going to end up being I'm going to ask you to round it to 3 decimal places, so 12.317. And then since this is a volume, we need to make that cubic feet. And so then there's our answer. Alright, I'm going to finish the next 2 problems on our notes in another video.